Oh, 1 o'clock.
Yeah, it's fine.
Welcome, everybody. Thank you for coming to Samantha's PhD defense. Hi, Samantha. You all know who Samantha is. And welcome to all those, also to those of you online. You're all, so I think Samantha's presenting for like 45 minutes or so.
Yeah.
And then we will have questions from the audience, please. All right. And then we thank the audience, and then you all go away, and then we have a separate Q&A session with the committee. And then if you want to stick around, you're welcome to hang out outside in the gorgeous weather, and we can call you back in when the results are. Okay. Anyway, other than that, oh, I'm Andy. I'm by the party. Samantha, over to you.
Okay, all right. Thank you, Andy, for that introduction. Wow. First of all, thank you to everyone for coming and being a part of this milestone. And a big shout out to hello to everyone online on Zoom.
Is the microphone working?
Yes, I think it is now. Surely. Okay. Can you hear me?
Yeah, Sam, we can hear you just fine.
Just checking in with folks online. Can you hear me? Okay, cool. We get a thumbs up. And we are also recording, by the way. Okay. All right. Without further ado, I'm really excited to present my dissertation to you all. Form follows function, follows gender, how social norms such as gender are not just contextual variables in engineering design. I'm going to argue that they are sources of technological change. And my research seeks to demonstrate how gender norms impact our understandings of design cognitions, how we think about design, design decision-making and behavior, and subsequently theories of innovation. And this matters because engineering design impacts nearly every aspect of our lives today. It mediates everything from our communication to our relationships, to how we work, the technology we use for our health. It also mediates how we interact with both the physical and the digital worlds. I would argue that few things in our lives today are untouched by design. And while design is often portrayed as a means to optimize or improve or transform our lives, which it definitely has, the benefits of design innovation are not distributed equally. And Coretta Perez documents this in her landmark book, Invisible Women. And she found that, well, we have a really big gender data gap, and that so much of our data is male normed, which has resulted in gender biased technologies and systems. And when I say gender bias in a design context, I mean a systematic and sometimes predictable devaluation of users and their needs and behaviors. And these bias outcomes don't just result in annoying products or phenomenons like pink it and shrink it, which essentially feminizes a product and makes them pink and smaller. These bias outcomes can result in some pretty serious harm for our users. For example, a study on car safety design found basically a crash test bias in that women and petite individuals and children are 73% more likely to be seriously injured and 17% more likely to die in car accidents. You might ask why? Well, it's because crash test dummies were modeled on male anthropometrics. We have other studies, and including a lawsuit on Apple Watches, which found that their blood oxygen sensor, for example, could not read through melanated skin. We also see that the design of life essential technologies, such as tampons, have not been innovated on in nearly a century. One explanation for this is, well, demographics. Engineers, we're less than 2% of American society today as it stands. And we look at the slice of the pie, right? Mechanical engineers represent probably the largest majority, in which 83% are men. Because of this, design researchers have studied gender in engineering design for decades. And existing empirical studies have investigated all sorts of things, from how designer gender interacts with concept selection, right? Cho et al. Found that novice male engineers tend to select their own designs over female engineers, for example. We see how engineers' default assumptions of the user tend to skew masculine unless otherwise prompted. And we also see that designer gender diversity does benefit design collaboration, but there's a trade-off. Women tend to feel less psychologically safe in mixed gender design teams. And I say all these together, I think these studies challenge the idea that engineering is purely an objective, rationalist approach of applying math and science to solve technical problems. And whether we want to acknowledge it or not, engineering design is equally a technical as it is a social process. But we have yet to examine how gender, not only as a demographic, but as a social construct, as a social norm, shapes design cognition and design theory itself. And this brings me to my gap. And my dissertation problematizes the fact that design theory, as it currently stands today, doesn't account for social norms such as gender. And because social norms or social determinants in design are not considered as critical explanatory variables, I argue that our design theory will just continue to support and perpetuate gender-biased designs. And I think I want to bring this to engineering education as well, because as we teach the design process, we often start with function, which is the desired behavior of the system, which is often represented by a set of goals, engineering constraints, customer needs. And then the designer attempts to discover that form that will support this desired function. And in many ways, I argue that this current epistemologist way of knowing and doing design looks at engineering design in somewhat a black box. And I'm going to argue and show you through this presentation that social norms are at the bottom of that pyramid. And when it is, it changes and impacts how we think about form and function. And so this leads me to my overarching research question of my PhD, which is, how does gender, as a socially significant structure, influence engineering design cognition, evolution, and innovation? And although my research is grounded in engineering design, in the field of engineering design, I realized I needed an interdisciplinary approach, which basically means you do twice the amount of work. And so I integrated theories and methods from social psychology, specifically implicit social cognition research, and feminist frameworks, specifically gender studies and techno-feminist theories, to provide this theoretical foundation for my research. And I tackle this question in three main ways as outlined here, through theory, behavior, and a case study. And through these studies, I sought to develop new empirical evidence that supports this argument, this claim that I made, that social norms can, and they always have been, critical explanatory variables in design theory. So in this first study, I asked, how do gender norms influence design thinking? And when I began this work, I found that no tool really existed to measure this. And you might be asking, well, how else have designers understood things like this? And a lot of folks have relied on what are called explicit methods of measurement, such as self-report surveys and questionnaires and interviews and focus groups. And these are all super useful for understanding things like customer feedback, interaction with the product or design, how designers think about a design process. But when we come to socially sensitive topics like gender bias in design, people might be vulnerable to what is called social desirability bias. That is this perception that people don't want to be perceived as having gender bias. For example, if you're asked your design colleague next to you, hey, do you think you're gender biased in your design practice? I agree. Most people say, no, I intend to design for everyone, and that is what I want to do. That's what I believe. However, due to this limitation, I adapted an implicit measure from social psychology research called the implicit association test, which captures automatic or implicit associations that people may not report or even be aware of. Before I get to how the IAT works, I first want to talk about implicit bias. And I think bias has usually a negative connotation. I'm here to tell you that bias, and like most cognitive scientists will tell you, it is fundamental to our human cognition. It allows us to make these split-second decisions and to survive back in the olden days. And know that the cougar here, although friend-shaped, is not a friend. And the bias that we tend to develop, right, is that the cougar is associated with danger. And psychologists have long argued that in our modern world, very technocentric world today, these implicit attitudes have come to reflect our social environment, of course, and with that, the social messaging, the stereotypes, the norms that we receive from our education, the media we consume, the cultures and religions that we participate in. And so IAT studies have found that basically the IAT has been linked to showing that implicit stereotypes have been shown to affect math and science achievements. I think this is really important. I think this study, this landmark study, is super important because it also indicates and it suggests that basically implicit biases do have behavioral outcomes. And I argue that designers are no exception to this as gendered and cultured beings in society. And so to talk a little bit more about how the IAT works to capture these kind of social constructs, the IAT is a reaction time computer-based sorting task that reveals implicit attitudes through reaction time differences to congruent and incongruent concept pairings. And so it basically works on this premise that closely associated concepts in the mind, for example, cougar is associated with danger, is more congruent and therefore faster to categorize and to sort and associate. Incongruent concepts, on the other hand, like the cougar is associated with safety, or maybe men and caregiving and women and engineering, might be slower to associate. And so the IAT is composed of these congruent and incongruent sorting task blocks that at some point in the test, in here, in a 5-block structure in block 4, it creates cognitive dissonance when we swap those concepts in our task. And so I took this concept and I ran with it, and I integrated gender value systems theories itself. And this is where I'm integrating techno-feminist theory into the IAT. And so the gender value systems theory, just a brief, it posits that gender norms, such as power structures or otherwise known as the heteropatriarchy, is structured by principles of hierarchy and separation. For example, where the male masculine being is considered superior to that of the feminized being. And roles and expectations are both ideologically and physically separate in our society. For example, the work and the home spheres, which have long been gendered and separate in society. So to embody that, I tested whether normative gender, for example, male and female, was implicitly associated with certain product characteristics. In this case, innovative, functional, and aesthetic domestic product characteristics, such as descriptors like technical and powerful versus stylish and colorful. In the second IAT, I was interested in, okay, so how do these product attributes, how are they implicitly associated with perhaps these gendered and separate spheres in society of the home and the work? And so here I tested basically functionally similar, but gendered pairs. And it should be appreciated that the participant had no idea they were pairing items like this. But what I mean by functionally similar is that, for example, the heat gun and the hairdryer. Obviously, they exist in very different spheres of society, in the work and the home spheres, but functionally, they're pretty much equivalent. They both blow ambient temperature air over an electrically heated heating coil. So with this new tool, I tested this with 159 participants from 4 different populations. I looked at both non-engineers, first-year engineering students, and upper division mechanical engineering students. And they all took the IAT on their own computer. So to give you an experience of the IET, we're going to walk through a couple of these blocks. In the first block, the participant will see, right, they have to pair one word into one category. In this case, we're going to pair aunt into female. So we're going to hit the J key on our computer as fast as we can. And we're going to continue on. And because we're going so fast, maybe we accidentally hit grandpa into female. A red error X is going to pop up. And this means that we then have to repair grandpa into male. And this will likely induce a time delay. In the next part of the test, right, we're comparing innovative versus aesthetic product attributes. And here, competitive would be paired into the F categories or the left side. So we're going to press the F key. And in this case, you notice I have blue and pink under parentheses. And in the test, I shortened it to actually one word color-based labels. And this was to help minimize activating explicit associations and hierarchy that engineers have when it comes to innovative versus aesthetic product attributes, but still keep it open and understand kind of that conflict between gender and product design. In the next part of the test, we have our combined task sorting block, where here we're going to sort stylish into the right side. We're going to press J. And this is where the test kind of creates that cognitive dissonance. And that's where we switch pink and blue on different sides of the screen. And perhaps maybe I see male. I'm going to quickly press the F key. That's incorrect. And we're going to have to then pair innovative into the blue side. So we're doing this over and over again as fast as you can for 7 blocks for my test. Okay. So we ran through our IET together, and when we look at the raw reaction times where we compare congruent to incongruent sorting tasks, we witness, right, this IET effect, which is this time delay, this time reaction difference. And basically this tells us that, okay, participants were faster to pair masculine gender, for example, man, boy, uncle, with innovative product attributes such as powerful, technical, innovative, and they were slower to pair basically the converse, where, you know, the male category was, paired with pink, which represented domestic aesthetic product attributes, and female category was paired with the innovative technical product attributes. So another way to visualize this is through the D-scores. And this is basically a representation of the direction and strength of those reaction times that we saw in the previous slide. And so here you're probably wondering, was there a difference between these sample populations? And with IET scoring, it's scored on a scale of -2 to 2, where above 0.65 indicates a very strong implicit bias. And here the results indicate that we did detect a bias between, or a strong implicit association between masculine gender and innovative functional product attributes, and for 2 populations, work-related products. So kind of distilling this, in other words, I argue that this implies that feminine associated products, for example, the hairdryer, might be seen as less associated with innovative product attributes in masculine gender. These implicit associations, I argue, may also create gendered associations even when products are functionally equivalent, as seen with the heat gun and the hairdryer. And I wonder that if designers are asked in a brainstorming session to come up with products that are powerful or high performance, I contend that they may be more likely to draw on masculine products as source inspiration, even if their target product is intended for women, for example. And so to close, this research provides, I think, that empirical evidence that gender norms do shape design cognition. And I believe that this is one of the first test instruments to kind of reliably measure that within a design context. And I also want to emphasize that in our test, and I didn't get to show these results, but there are certain words, for example, like industrial, innovative, high performance, that kind of are readily associated with kind of masculine framings of innovation. And so when constructing design prompts, these are words to be aware of and to take caution when we write those. Okay, so this brings us to part 2. And so I'm really interested, right, in this idea of like, how do these implicit gender associations that we could detect in the gender design IET that I created, how might these manifest in design decision-making? And more specifically, how might they manifest in early stage design tasks that tend to rely on quick automatic judgments? So to understand this, I ran a behavioral study of design thinking and decision-making. And you might be wondering, why the early stage design? And early stage conceptual design is widely acknowledged as one of the most important and cognitively challenging components of the design process. And designers must often work under a confluence of factors, including a lot of design uncertainty, ambiguous user preferences, and technical requirements, time pressures, of course, complex social and gender dynamics, and limited resources. And so, while not always intended, most engineers will tend to rely on their past experience to navigate this phase. I'm definitely guilty of this. But as we found that when we use our own assumptions, when we rely on our own experience, we tend to run the risk of perhaps transferring our own gendered assumptions into the design process. And we see this with the male-normed car safety design, where, right, women were found to be more likely to be seriously injured or die in car accidents. And I argue that even though these designers intended to design for all, I don't think they had malintent, their implicit gender bias or assumptions may have led to the fact that crash test dummies were modeled on male anthropometrics. And so this brings me to an existing weakness in design cognition research. And it's the fact that design reasoning and decision-making are often seen as intentional, explicit actions by the designer, except for things like design fixation, rather than as socially influenced or socially constructed. So to study this, I ran a behavioral study, a two-part behavioral study where folks took a timed design activity and then also completed the gender design IAT, as we saw before. In the first part, these mechanical engineering participants they read and interpreted a design prompt, which positioned them as part of the Apple Watch design team to create the next generation Apple Watch. And here we scaffold them with 4 areas of design improvements and ask them to generate 5 concept features and provide justification for why. We also provide a space below for them to sketch their ideas. In the second part of this time design activity, we ask them to then rank their design concepts in order of importance. And this is kind of under the notion and reality that design teams cannot pursue all design changes all at once realistically. And so we had them rank them and then provide justification for that. And then in the last question, in part 3, which I know is kind of hard to see, but I asked them to think of the most common user for the next generation Apple Watch. And this was positioned last, and it was intentionally binary because I wanted to kind of like force people to think about gender in relation to users and design, and understand whether and how they engaged with that question. So to interpret all of these responses, all 58 responses, I used an established codebook developed by my collaborator, Casey Simone, and I last year, and we used this to qualitatively assess how participants encoded gender in their tasks to conceptually innovate on the Apple Watch. And so basically this codebook here, which is also inspired heavily by gender design and marketing texts, this codebook allowed me to identify and categorize design elements into 4 categories. For example, it's hypermasculine, feminine to hyperfeminine. And to just touch briefly on that, I wish I could talk more about this, but we don't have time. But basically, masculine views of innovation, everything from the watch body to how we conceptualize product improvement. Masculine views of innovation tend to prioritize performance, technicality over other ways of product betterment, even if it improves it or not. On the converse, feminine views of innovation in our codebook tends to prioritize aesthetics or interactive or relational features. So using kind of this lens, it's based on gender value systems theory as well. I was able to determine in these participant responses how they viewed functional and aesthetic attributes. So from this qualitative study, we were able to glean some pretty interesting patterns from their responses. And the first thing that we found was there was an overall deprioritization of aesthetics when designing to innovate. We saw things like, aesthetics aren't as important as functionality, and the looks don't matter much. I think this is interesting because a lot of marketing studies show that, right, we tend to buy things off the way they look, which is directly related to their design and aesthetics. The second thing we found was two. Masculine coded aesthetics were proposed often as functional attributes. This can be described here when one participant said that, well, I want to propose carbon fiber frames for the Apple Watch because they look really cool. And here, they actually categorize this as their first design recommendation, not because of aesthetics, but because of a functional purpose. And so what I'm trying to say is that we saw a lot of participants choose carbon fiber as their material selection improvement. And I would argue that, yes, carbon fiber is light and strong, but as a composite laminate, it is really difficult to work with, let alone mass manufacture. So we also looked at the relationship, right, between rankings and user gender. And so this is really honing in on that third question of the worksheet, which asks participants to identify the most common user for the next generation watch. And right, I provided only three options: men, woman, and other. And I thought it was really interesting that, yes, 50% of participants chose within this gender binary. I think it's also really interesting that 40% decided to choose other. And some of those responses are listed here from the other category. And I couldn't add all of them, but just some of the top ones I thought were interesting were that, one, a lot of people said, I think both genders should be equally common as users of the Apple Watch. And that all, because I'm not sexist. And some people also maybe resisted the idea that gender is relevant to user demographics. And some people are like, well, I think it's rich people, which not wrong maybe, but maybe rather than gender, it's like younger people. And so I think what's really interesting is that I think if 40%, if not more, right, claimed egalitarian views of gender, or maybe didn't want to consider it as relevant to user demographics, I think this is interesting because it kind of contrasts the fact that participants often promoted kind of these masculine framings of innovation that prioritize improving functionality at all costs, kind of mindset. Okay, so if you remember, they also took the gender design IAT, and participants exhibited a high positive IAT score. Which is probably to no surprise, but it indicates, right, and it complements the qualitative findings that, they demonstrate a strong implicit association between masculine gender and innovative functional product attributes. And so I think what this says is that their implicit association scores tell us something that, and maybe complements what they wrote and did in their design tasks. I think it's also really interesting is that, well, one, the majority of these participants, 80%, had never taken an IAT before or heard of it. But despite this, I think it was really interesting to see that most participants could gauge what the gender design IAT was about, which brings me to my closing thoughts on this study. One, putting this all together, we hypothesize that design methods that tend to rely heavily on fast, intuitive mental associations, such as analogical reasoning or unstructured brainstorming or concept generation, or even scenarios where those time pressures induce that kind of thinking, these methods might be particularly susceptible to that transfer of implicit associations, for example, of social norms, of gendered assumptions into the design process. And also to reiterate, I think what was really interesting from this study is that despite 40% reporting kind of more egalitarian views of gender, or maybe not even engaging with it, participants still prioritize masculine norm values of innovation and product betterment. And then touching back on the fact that 80% had never taken the IAT, and that the fact that a lot of them actually knew what it was about by the end, I think this shows really a lot of promise for the gender design IIT as a pedagogical tool for building critical consciousness in our students and engaging folks in conversations of gender and social norms and design. Okay, so we spent 2 studies understanding how gender norms manifest at kind of these implicit levels and perhaps in design behavior itself. And so I'm actually really interested in how do these collectively shape technology trajectories over long periods of time. And I conducted a historical case study on the sewing machine, which I argue is one of the coolest and most important inventions of the 19th century to develop theory to answer this question. So to examine this, I looked at one of the most well-known models of technical change called the technology lifecycle model. And it goes something like this. We start with the technological discontinuity, which is whether it's the introduction of new science or innovation or radical performance improvements. For example, for millennia, we've sat on the floor until the invention of the chair. We're then ushered into what's called the era of ferment, which is characterized by a lot of ambiguous user preferences, technical uncertainty, and competition. Should the chair have 3 legs or 4 legs? And then we settle on what's called a dominant design, which basically kind of establishes the status quo. In this case, chairs typically have 4 legs, a back, kind of uncomfortable, but this embodies basically well-established preferences. And then this is followed by what's called the era of incremental change, in which we see minimal change to the dominant design itself. And I argue a lot of our technologies probably sit in this category, just waiting for the next technological breakthrough. And while this model is generally accurate for a wide variety of products and understanding their technology trajectories, I argue that this model does not predict the technology trajectory of many gendered technologies or marginalized technologies like sewing machine and more. And through this, I realized that conventional models of technical change do not account for social norms like gender. So to develop theory for this, I conducted a technical historical case study analysis of the sewing machine. And I looked at dozens of sewing machine patents from the early 1800s and onward to the 1900s. And I narrowed it down to just 10, or else I'd be here forever. And I applied a feminist critique to the technology lifecycle model of the sewing machine. And in applying this feminist lens, it allows us to explicitly center gender, as we've done in the previous studies. It allows us to center gender in technological development. And this informed the creation of a new social norms model of technology trajectories. But first, I want us to look at the original kind of the technology lifecycle model I've seen from the conventional model of the sewing machine. So in this era of ferment, in kind of the 1800s to 1850s, we see dozens of feasible designs pop up. These are just 6 that I thought that are part of my study, and also I think some of the most interesting ones, all of which were created or patented by men, which eventually led to the dominant design that was primarily marketed to women. And these marketing ads from the 1800s are just a couple that I found, but it shows something pretty clear, and it shows that the sewing machine was aggressively marketed to women at that time. And so I kind of argue, so from the marketing of the sewing machine to the entrance of it into the home as a primarily domestic technology associated with women's work, I argue that gender and gender norms play a significant role in the sewing machine's technology life cycle. However, from a purely just conventional view of the technology life cycle model, it would have never captured this trend. So I developed theory to do just that. Here, I present my theory, as you can see, that builds upon the original technology lifecycle model, which I call the social norms model for technology trajectories. And here, as you can see, I tend to explicitly account for the influence of social norms at each stage of the technology lifecycle. For example, up top, the disruption of social norms, we can see that instead of perhaps just new science or radical performance improvements, that social norms and the breaking of social norms or even social revolutions can be a source for technological discontinuity. Instead of assuming well-established preferences, the dominant design or the era of established norms shows how powerful social norms at the time, for example, Victorian gender roles and expectations, help solidify the technology's form and function, or basically the fact that the sewing machine was tied to the home during this time period. So I argue that this model and this new way of looking at technology trajectories helps us understand how gender, and for example, the gender imbalance between the designer and the user may have led to primarily aesthetic changes to the sewing machine over prioritizing ergonomic and safety considerations of its majority user, in this case, women. So to close, while my research focuses on the sewing machine, as we've seen early in this presentation, the sewing machine is just one of many products that illustrates, I think, how social norms shape product trajectories. And that if we don't consider gender norms in design, I think we will just continue to exclude user needs and also miss out on alternative forms of innovation when technology is no longer a constraint. So what I really want to emphasize here is that technology and design are not neutral. And therefore, we cannot be neutral in our design theories and our theories of technological change. And our results demonstrate how the feminized identity of an artifact, of the sewing machine in this case, influenced and also constrained its design transformation dynamics to address safety or ergonomic considerations. And the social norms model of technology trajectories that I developed, I argue, opens up space to explicitly account for gender as a critical explanatory variable in trajectories. I think also that this means that design theory must account for how social norms shape design outcomes and also the direction of technology trajectories. So through this work, I answered these three questions. How do social norms influence design thinking? How do social norms affect our design decision-making? And then lastly, how do social norms influence long-term product trajectories? There are more papers here, if you're curious, that extend and also go into other lines of work. And this brings me to my closing thoughts of this talk. And the research conclusions I want to highlight here and leave you all with is that feminist-informed design theories and tools do something that conventional design theories cannot. And it's that they are responsive to changing social norms. And I think this supports alternative or even radical forms of innovation when technology is no longer constrained. I think this research also encourages us to rethink metrics of design innovation that we have found are co-constructed with ideals of masculinity. And I think this also allows us to look at the fact that there are many sources of innovation beyond just technocentric framings of innovation. And then also to touch on kind of this rethinking, I think, of course, right, biases come from our social environments. And then I think as engineering educators, we have the power to reshape these for our students to support more diverse and broader ideas of engineering design. Future work includes expanding upon a lot of this work, especially the gender design IAT, and also integrating and looking at other social factors in their relationship to design. So I began this talk with saying that engineering design has tremendous impact on our lives. And the fact is that when we leave out social norms in the design process, there can be some really serious consequences. But I believe like any human constructed intervention, such as design, we can work to make it better so that design theories will instead be a part of feminist reimaginings, such that these headlines that we saw earlier will cease to exist. With that, I'd like to thank my thesis committee. First, I want to thank my advisor, Andy Dong. This research would not be possible without your support and guidance. Thank you for trusting me and following this rabbit hole of feminist design and for sharing intellectual space with me for the past 5 years. I want to say thank you to Chris for your collaboration over the years and for welcoming me into the world of cognitive science. I think you were the first person to tell me anything about the IAT. I think that sparked a whole thread of research. No? Okay. All right. I want to give a shout out to Bryony, who's on Zoom. Thank you for your support throughout the years. And also, I think a highlight is getting to TA for you in your design for manufacturing course, which helped me become a better engineering educator. To Christina Wilson, thank you for your guidance and our conversations throughout the years in both my work and as I move forward into research and academia. And then lastly to Callie, who has been my professor in the GCUP program, which is a graduate certificate in college and university teaching here at OSU. Thank you for supporting me in transferring from student to scholar to educator. Okay, a couple more slides, acknowledgements. I'd really like to acknowledge my collaborators. I have had the privilege of meeting so many smart and kind and wonderful people throughout grad school. Casey Simone Bayeses at UC Berkeley, Amy Huff at the College of Business here at OSU, Fatima Kiani and Christine Toe, Nebraska and James Madison, Anna Schauer, Anastasia Oshowski at Purdue, and Rima now at Melbourne. It's been a pleasure getting to meet you and get to work with you all. I'd also like to thank the Design Engineering Lab, which has been my home for the last nearly 5 years, home to me and all of my plants. Thank you to everyone in this picture, Abraham, Amin, Zara, for making the lab such a welcoming space. I will miss you all. Next, I'd like to thank my family. For those of you who do not know, after my first year of grad school, I had a major climbing accident where I broke my back, my neck, and my arm, suffered many other injuries. And I think in that day, like kind of my life turned upside down, and I literally would not be standing here without my family who helped me recover in peace and safety, and taking me to a bajillion doctor's appointments and set up a huge GoFundMe. Let's shout out to my sister Andrea. And it helped me, learn to walk, and amongst other things, didn't expect that in grad school. Thank you to my mom, my dad, and my twin sister Andrea, my Popo and Gongon, Uncle Kevin, Auntie Jenny, and thank you for all your love and support throughout this journey. I'd like to thank all of my friends all across the world at this point who gave me a soft place to land, I think, during my accident recovery and helped me kind of recover and reconnect with kind of a new body, new mechanics, and a way of experiencing nature and climbing and just being in the outdoors again. And I have so many people to thank for this. Saria, Roberta, Johanna, Karen, Kyle, Kanchan, Juan Carlos and Steph, Deanna, Sammy, Skylar, and just so many more. Thank you for your support throughout the years and support me going back to grad school. I'd also like to acknowledge Corvallis Climb as a Color, which is an organization I found myself creating in 2020 and 2021. And I never thought that this path would lead me to the role of community organizer, but it's been an absolute honor getting to organize and use my engineering skills for good and to create this pocket in the community. I've met so many wonderful people throughout this who've become lifelong friends. And thank you for helping me become the person I am today. A quick shout out to my medical care team. I won't show you the other gnarly pictures, but this is me in airlift. And also just shout out to like all the great medical professionals who, even our brutal American healthcare system, have so much compassion for their patients. And I just wouldn't be here mentally and physically without them. And then last but not least, I'd like to thank my partner, Sydney. Your support, encouragement, and listening me rant about bad design like throughout 5 years. I was like, that's bad design, that's bad design. Has meant the world to me. And I had no idea to find the love of my life in grad school and after a major climbing accident. But I'm so glad our paths crossed. And I still say this, that you're the best thing to happen to me and the best thing to come out of a PhD. So with that, I will take comments. Thank you.
You want to check the chat, if there are any questions that.
Oh.
Question?
Yeah, I'll check.
Other than that, we open up to the general audience. Oh, and also for folks online, if you have a question, you can either raise your hand or type it in chat for Samantha to answer. Anyone else here, the thing you want to know about the research? So,
Yeah, Kyle.
So if you had unlimited funding, how would you apply this work? Like, how would you take it from theory to?
Yeah, thank you for that question. For those who can hear, if I had unlimited funding, and if we didn't have huge funding budget cuts right now, what would I do with this research? Where would I take this next? And I love that the scope of that question, and I think learning to be creative as an academic is such a skill of resilience and skill you learn. But what I would do with this research, there are so many ways I think I want to see this. I think it is putting into practice, right, feminist-informed design theory into and actualizing that. And I think, this kind of fancy operationalizing kind of these feminist-informed values of design and innovation, there's still a lot of work to do. And all that to say is I really hope to move my work into looking at other forms, like other social norms, like disability in design, for example, and working with communities to actually implement some of this work. That is ultimately like the communities I want to serve as a design researcher, and continue building upon that. So, yeah. Yeah, Devlin.
I'm gonna assume that your research grapples some engineers' identities, describing it as a process that they don't necessarily understand or see in their work. For us, do you have any advice as research mentors of how to set you up for success when you might be pissing the dean off just for writing a paper or something? Are there things that work, or I mean, as comfortable as you can be, and things that may have been helpful?
Yeah, no, that's a great question, Devlin. One thing I've found doing research in gender design, it is very controversial. It's very political in engineering design circles. I received quite a few interesting reviews on the papers I've written, which shows that we still have, a long ways to go in terms of understanding design outside of its like kind of technical bubble and basis. In terms of advising students, I think I've been like lucky to like have a lot of self-selecting folks, really interested in this work. But yes, for the 99% who still understand design as the way we teach it, my hope is to use tools like pedagogical tools like the Gender Design IAT as kind of this like bridge where it doesn't quite say gender right in your face. Yes, it's a gender design IAT, but I feel like it can be a really interesting conduit to opening up these kind of conversations and self-reflections around, okay, gender isn't just the demographic. It's also embedded and entrenched in the ways we think about innovation. When you think about product betterment and improvement, there's these kind of masculine ideals, which and hence is a reflection of gender norms today. But I think I'm still asking that question myself. It's like, how do you reach the engineering student who kind of would totally detest this? And I think it takes a lot of work to kind of turn the boat. But I hope eventually we can have these conversations and dialogues that help raise kind of critical consciousness. Yeah. Okay. Well, if no further questions, thank you so much for coming and joining. To everyone on Zoom, thank you so much for tuning in. We're going to have the closed door section right now, and so I'm going to stop the recording and end the Zoom. Okay. All right. Thank you. Oh, just kidding. Zoom. Stop recording. Okay. Yeah. Thank you. Thank you, Callie.